All right, you guys, in the previous videos, we looked at expanding logs. So they gave us one single log and our job was to expand it as far as it could go. Now we're going to look at trying to write multiple logs as a single log. So the directions for these say write each of the following as a single logarithm. So A, we have log base A of 7 plus 4 log base A of 3. Okay. All right, so if you are asked to combine these as a single log, the first thing that you need to do is make sure that you have the same log and they have the same base. If they do not, you cannot try to simplify this problem. The bases and the logs have to be the same. So as I'm looking at this problem, I have log base A, and in the second one, I have log base A. So I'm fine. They have the same log raised to the same base, so I can use the properties, okay? So the same properties that we used before, okay? So before when we were expanding, if we saw multiplication, okay? Multiplication could be expanded using addition, okay? If we had division, we could expand it using subtraction, okay? And if we had powers, they became coefficients, okay? When we used these properties before, we were moving from left to right. These same rules still work if you move from right to left. So this time, if we see any addition, we're going to change it into multiplication, okay? If we see any subtraction, we're going to change it to division. And if we see any coefficients, we're going to change them into powers, okay? So the rules are just going to work in reverse. So the first thing that I'm going to look for, I'm going to look to see, do I have any coefficients in my problem, okay? So in the front of this expression, I don't have any. But in this one, there's a 4. So according to our rules, that 4 can become an exponent, okay? So that means I'm going to rewrite my problem as follows. Okay, so I have log base A of 7 plus log base A of 3 to the 4th. All right, we can simplify 3 to the 4th. That's going to be 81. Okay, and then I have addition, okay, between those two logs. So addition gets condensed by multiplication, okay? So this is going to become log base A of 7 times 81. All right, and I can simplify that. 7 times 81 is 567, okay? So that's our answer. Okay, we have one single log. All right, let's try B. So B says we have 2/3 natural log of 8 minus the natural log of 5 squared minus 1. Okay. All right, so the first thing we have to check is to make sure we have the same logs that have the same base. Well, we have natural log on this one. We have natural log on the second one. So our rules are in play. All right, the next thing I'm going to check is to see, do I have any coefficients? Okay. Well, I have 2/3 on this one. I have no coefficient on the second one. So this 2/3 is going to become an exponent. Okay. It's going to give me natural log of 8 to the 2/3 power minus the natural log of 5 squared minus 1. All right, 5 squared is 25. 25 minus 1 is 24. Okay. All right, let's simplify 8 to the 2/3. Okay. So you can punch that into your calculator, or if you remember transferring rational exponents into radicals, 8 to the 2/3 power is the same thing as the cube root of 8 raised to the second power. So the cube root of 8 is 2, and 2 squared is 4. So we're going to have the natural log of 4 minus the natural log of 24. Okay. Now in between these logs, I see subtraction. Okay. And by our rules, anytime you have subtraction, subtraction can be condensed using division for logs. So you're going to move from left to right. So you're going to have the natural log of 4 divided by 24. Okay. All right, let's see if that reduces. So 4 over 24 becomes 1 over 6. Okay. Now, anytime you see a 1 in the argument of a log, okay, that 1 cannot stay there, okay? You're going to have to reduce it out. The reason why you're going to have to simplify it out is because the natural log of 1 equals 0, okay? So we don't want to keep it there. So I'm going to expand that log back out. So we have division. Division can be expanded using subtraction. So we're going to have the natural log of 1 minus the natural log of 6. Okay. The natural log of 1 equals 0. So our answer is the negative natural log of 6. Okay. So be careful. Anytime you see a 1 left in your argument, you're going to have to expand that out. Had that been any other number, a 5, a 7, we could have left it just where it was. So be careful for this. Okay. All right, let's try the last one. So we have C. All right, C says log base A of x plus log base A of 9 plus log base A of x squared plus 1 minus log base A of 5. Okay, now this is a much longer problem. Our goal is still to write it as a single log, okay? And we always want to move from left to right. So I'm going to condense 2 logs at a time, okay? So I'm going to look at these first 2, okay? So in those logs, the first thing I'm doing, I need to check to make sure I have the same log that has the same base. So I have log base A, all of these are log base A. So we're good, okay? Our rules will apply. All right, so in that first log, I'm looking to see, do I have any coefficients in the front? I don't, so that means I'm not going to have anything that's going to change into a power. But between those 2 logs, okay, I have an addition sign, okay? When we are condensing, addition turns to multiplication. So it's going to be log base A of x times 9, okay? You can rewrite that as 9x, okay? And then we're going to continue the problem. Plus log base A x squared plus 1 minus log base A of 5. All right, and then I'm going to work on condensing the next 2 logs. So in the next 2 logs, I see addition is in between them. So you condense addition by multiplication. So it's going to give me 9x times x squared plus 1. I'm going to bring the other log down. Okay, now I only have 2 logs left, so I'm going to condense those. All right, and I see that between those, I see subtraction. So we condense subtraction by division. So I have log base A, 9x, x squared plus 1, divided by 5. Okay, that's going to be my answer. Awesome.